Hello, good morning, everybody. Welcome to the first HYPER AI webinar. My name is Silvana Masella. I'm part of I'm the CEO of Trust IT. We're part of the HYPER AI consortia. We lead the efforts around communication and dissemination exploitation. And we're thrilled to have with us a super group of experts who will be discussing about revolutionizing big data processing applications with self-managing cloud-to-edge resources. I'd like to thank first and foremost Diego and Veronica on behalf of Trust and our other colleagues who have helped put this webinar together. So if we go through onto the next slide. And thank you all for joining us on this Wednesday morning, which is lovely and sunny here in Pisa. We hope it's sunny where you are. Before we start talking about the goals of the webinar, we do invite you to actually indicate any details about yourself in the chat. We'd love to find out about you so we can follow up with you after. If you're working on any developments that you're going to hear today, do write and tell us about this in the chat. And so that's wonderful as well. So the goal is to, as the title explains, revolutionizing big data processing applications with self-managing cloud-to-edge resources. HYPER AI is one of a set of different RIA projects funded under Horizon Europe. And that was under the Horizon Europe called Cognitive Computing Continuum Domain, Intelligence and Automation for More Efficient Data Processing. And what we want to be able to do is to create a closer synergy with the other clustered projects that have been funded under this same call. But for today's effort, it's solely concentrating on HYPER AI. There are going to be some key concepts that are going to be discussed around the architecture, so on computing swarms and self-chop principles. And at the same time, it's nice that HYPER AI has a set of pilot projects that are under the thematic areas of mobility and automotive, Industry 4.0, healthcare, green energy, farming and agriculture, all relevant topics that are part of the digital agenda of the European Union. We see these in the reference documents that have come out from Draghi and Enrico Letta recently. And it's super that HYPER AI has these concentrated as part of their main topics going forward. So just a few housekeeping for you all. I said about the chat, please do make it. We'd like to have as dynamic chats as possible. So please don't be afraid to write here, tell us who you are. We will record this webinar so you can go and access this after. We encourage you also to enter any questions in the Q&A. And please follow the chat, receive links. And if you want any information about the project, please make sure that you do follow us on our various social media channel that you see here at the bottom. So going through with our agenda, you've heard from me just now on our goals of today's webinar. I'll then move on to pass the floor to Thanasis Moustakis, who will give an overview exactly and dig deeper around HYPER AI. Then from a research assistant at CERF, core goals and vision will also be carried out by Thanasis. Then we're going to move to the technical approach, and Jacopo Castellini, a scientific collaborator at SCO, will give this overview. We discussed technologies and innovations by Vasilis Papataxiaris, and Manos Vampis will conclude on giving an overview in the roadmap and milestones going forward. So with that, now no further ado, let's move on to Thanasis, who's going to tell us about, before we do, excuse me, just some numbers for today. You see who we have in our audience. So we had 766 who are registering. So we hope that they do come on board in shortly. And it's good because the categories of people who are in the audience do then relate to the pilot thematic areas that we're working on. So it's good also that those developers on the call can hear insights also from the technical innovations that we'll hear later on from our speakers. So thank you again, and over to you, Thanasis. Thank you.
Thank you, Silvana. Hello all, my name is Thanasis Moustakas and I am a research assistant at CERN. Let's start with the presentations. Can you see my screen? Probably yes.
Yes, that's all good, Thanasis. You're ready to go.
Great. Let's go. So, what is HYPER AI? The project's name is a hyper-distributed artificial intelligence platform for network resources automation and management towards more efficient data processing applications. HYPER AI is a cutting-edge project that develops a hyper-distributed AI platform, and it aims to automate and optimize network resource management across the Internet of Things, edge and cloud layers. HYPER AI is an innovative approach that utilizes swarm computing and autonomic systems to enhance scalability and efficiency. By swarm computing, we refer to a set of devices that work together as a whole to achieve a common goal. In the next slide, we can see some general information about the project, like the project name that I mentioned in the previous slide, the project number, the call and the topic that it refers to, and the type of action. This is a Horizon project, as Silvana also mentioned before. The project started in the 1st of April 2024. You can see the total budget among different partners. This is a lump sum project. The total duration for it is 36 months, and the consortium is comprised from 15 partners in total, coming from 8 different countries. More specifically, we have 12 European Union partners, 2 Swiss partners, and 1 international partner from South Korea. The main objectives of this project is to enable seamless, intelligent, and hyper-distributed data management, to facilitate collaboration between cloud edge and IoT infrastructures, empower diverse industries through advanced AI and data-driven insights, enhance operational efficiency across European data ecosystems, support secure and decentralized data sharing and processing, and driving innovation in artificial intelligence-driven automation, optimization, and resilience. Why is HYPER AI important? HYPER AI aligns with European Union strategic goals for digital transformation and sustainable development, and focuses on advancing digital technologies to improve data processing and resource management. The expected impact of the project is an improved European leadership in the global data economy, maximized social and economic benefits from wider and more effective use of data, and reinforced Europe's ability to address urgent societal challenges like crisis management and clean energy. In the following 2 slides, you can see each partner and link to their respective site. So I'm going through both of these quickly. In HYPER AI, we have 5 project use cases. One is about manufacturing. It's Sabo. The other one is about green energy, Enea. The third is about mobility and automotive, VAF. The fourth is farming and smart agriculture. And the fifth is about healthcare. That's the general overview of the project. So, are there any questions?
Thanasis, I think maybe a quick consideration, either yourself or Yakovos. I wrote in the chat as well, and I'm just trying to see if I can then send this to everyone in the chat about the South Korea organization, because that's obviously a novelty. They're going to have a much more prominent role in the future under Horizon Europe. So can you give us a couple of details on there, please?
Yeah, in South Korea, they're working with healthcare data from animals, and they're trying to predict next pandemics and stuff like that. So we aim to help them with efficient data processing close to the source where the data are generated.
Okay, that's super. Thank you, Thanasis. I think you're next up. If we don't have questions, to move on to the core goals and objectives.
Okay, so
No, wait. It's more the vision actually. You're going to give that as well? Yeah.
sorry. Yeah. I'm
Okay.
going to the next presentation. Yeah. So let's proceed to the core goals and the vision of Hyper AI. Okay. Let's start with the project overview. The main goal of the project is to create an innovative AI platform that enables hyper-distributed computing across cloud, edge, and IoT layers, as I also referenced before. The core idea is to shift computation closer to data sources using intelligent swarms of nodes for running some models on this data. Basically, we want to work with the data closer where they are generated, and to leverage decentralized artificial intelligence or machine learning to achieve efficiency, scalability, and interoperability. Why this matters? We can handle the ever-growing data demands of modern industries. As more devices are integrated in these industries, we have big loads of data that ideally could be stored where they're generated, and we can process them there. We also support real-time, reliable, and efficient decision-making at scale. Trying to go to the next slide. Yeah. The key features of Hyper AI is decentralized intelligence. We enable swarms of autonomous nodes to collaborate between them in real time. So we reduce latency and optimize resource usage by processing data locally. Also, it is a scalable and adaptive ecosystem which seamlessly integrates diverse computational layers like cloud, edge, and IoT, and dynamically adapts to changing workloads, energy, and network conditions. Also, another feature is that it achieves robust security and privacy. It builds trust with distributed ledger technologies and protects sensitive data using advanced encryption and federated learning. Also, processing the data closer to where they're generated, this also enhances security and privacy. Next, it achieves performance boost as accelerated processing by bringing computation closer to the data source, and enhanced energy efficiency and reduced communication overhead. Another strategic benefit is that it supports critical sectors like healthcare, manufacturing, agriculture, energy, and mobility. These are practically the use cases that I presented before. And the European leadership, as it reinforces Europe's role in the global data economy through cutting-edge AI innovation. The vision of Hyper AI is to lead the future of adaptive, decentralized computing, setting new standards in scalability and efficiency. What are the challenges in data processing? Modern challenges in data processing applications include data abundance, as growing volume and complexity of data generated from IoT and edge devices. We have centralized systems limitations, as high latency due to distant data centers, bandwidth bottlenecks and high communication costs, and inefficient energy consumption and resource utilization. So there is a need for innovation here. A paradigm shift to decentralized, intelligent, and adaptive processing systems is critical to overcome the previous barriers. Let's talk about the computing swarms. Optimized computing swarms for data processing. The core concept here is that distributed swarms of intelligent nodes collaboratively process data closer to its source and minimize latency, while at the same time optimizing resource usage. The key features are the dynamic resource allocation, as the real-time workload distribution across nodes based on data availability and efficiency. Localized intelligence, artificial intelligence and machine learning algorithms execute at the edge of the network, ensuring faster insights. And autonomous functionality, as healing and self-optimizing mechanisms for continuous operation are set. The advantages are reduced dependency on centralized data centers, improved energy efficiency and cost savings, and enhanced reliability and real-time responsiveness. So what are benefits to data processing applications? Enhanced performance, as faster processing with reduced latency happens, and real-time analytics for critical applications like healthcare and manufacturing. Another benefit is scalability and flexibility, as seamless handling of large-scale applications across diverse environments is said. Energy efficiency, we have reduced energy consumption by limiting data movement, and some industry use cases for that is we can achieve precision agriculture as automated irrigation and monitoring systems are supported by HYPER AI. Also smart mobility, real-time artificial intelligence for autonomous vehicles, and green energy efficient simulations for environmental stability. The impact is that we can revolutionize data processing for modern industries by combining speed, efficiency, and adaptability, which are critical. Okay. What is our vision for the cloud, edge, and IoT optimization? We aim to create a unified computational ecosystem. The main objective is to seamlessly integrate all these layers to deliver scalable, efficient, and adaptive services. And the challenges that we aim to address are fragmentation, which means lack of interoperability between these layers, latency and bandwidth. We aim to address inefficiency in moving data to centralized cloud systems, and resource utilization, where suboptimal use of computational and storage capacities are going to be solved. The goal is to enable a cohesive continuum of computational storage and network resources. The key approaches for improvement are distributed resource management, where real-time allocation of resources based on workload, energy, and latency needs, etc., is going to be addressed, and autonomous optimization of computation and storage at the edge to minimize dependency on the cloud. Another area for improvement is the seamless data flow, where integrating IoT devices with intelligent edge nodes for localized decision making, and reduce data transmission to the cloud, conserving bandwidth and improving response times. Next is intelligent networking. This is achieved by use of predictive models for traffic management and congestion reduction, and optimized pathways for low latency communication across layers. What are the project's basic impacts on each service layer? In the cloud services, they can offload non-critical tasks to edge and IoT layers, freeing up computational power, and they can efficiently pool resources for large-scale data processing. Let's go to the edge layer. We can achieve real-time processing and analytics near the source of the data generation and adaptive decision-making with reduced latency and energy consumption. As for IoT devices, we can enhance device coordination through edge intelligence and make efficient use of these limited device resources for prolonged operation, as some of these IoT devices can run on battery, for example. And the outcome is a robust, scalable, and efficient ecosystem enabling faster, smarter, and greener applications across industries like healthcare, manufacturing, energy, and etc. So that's all for these presentations. Are there any questions? I see them in the chat. Probably.
Thank you, Thanasis. Super. Let's do a round of applause for you. Thank you so much. Marco, actually, and I was just about to write to him. Marco, Jan, thank you. Marco's working on open source. I'm going to pose the question to you, Thanasis. How is open source reflected in the work that you're doing from a technical point of view in Hyper AI? A few considerations, if you can.
Yes, we have already set up with the help of our colleagues in Eclipse a GitLab repository where we aim to upload parts of our code in order to be available to the public.
Okay.
Hi, Silvana, can I add also something on this aspect? I can chip in.
Yeah, I mean, if you can you introduce yourself to the audience?
Oh, yeah, sorry, yes. So it's Iakovos Michailidis. I'm a deputy project coordinator of the project of Hyper AI. And I'm a postdoctoral research associate in Center for Research Technology, Hellas, under the Information Technologies Institute. Nice to meet you all, first of all. So about open source aspects of the project, I mean, aside from Eclipse's, let's say, participation, setting up the GitLab and actually identifying parts of our work that will be also launched in an open source manner. So creating a community and also, let's say, working with external contributors as well that might be interested in this direction. We also work on, we capitalize actually on open source, on existing open source solutions like Kubernetes, building on top of these solutions, of these frameworks, in order to achieve the goals of the project actually. So hyper distributing decision making and big data intensive applications execution as much as possible. So pushing everything, decision making, self-decision making, self-coordination, and execution of applications as much as possible towards the edge of the network. And of course, aside from Kubernetes, we are also working on, let's say, open data models and open standardized representation models for APIs representation and system status representation as well. So we capitalize, we don't generate only open source, but we capitalize on existing open source frameworks as well.
Excellent, thanks, Iakovos. And I know we have a dedicated task within the project all around standardization, so it's absolutely crucial. Thank you, Marco, for that. Also nice input from Melanie on working on engineering swarm intelligence. Now, you know, we like to multitask on here. That's why these chats are so important. We might not be in a room drinking coffee all together, but having you online, it's a great way to find out what others are doing. And you never know, synergies happen very, very quickly. So do please exploit the chat function because we will be reaching out to you. Thank you, Thanasis, that was great. And well done for sticking to timing too.
Sorry, Silvana, to intervene. Yeah. We have a question, I think.
Oh, yes. Okay. Horvii Ratkovic, apologize for my terrible pronunciation, who would like to pick up this. What are some key methodologies and technologies you plan to use to achieve your objectives? We are going to have this as part of our presentations later on. If anyone wants to say something immediately, Jakubos, you wanted to the floor?
Just to, in a nutshell, because it's going to be analyzed afterwards. We are using, the aim is to use semantics for representation of applications, semantic-based, let's say, representation for applications and system status. About decision making, we are aiming to work on distributed, let's say, optimization techniques like multi-agent RL, reinforcement learning approaches for coordinating a swarm of autonomous working nodes in the end, just to use also terminology related to Kubernetes. And also deep learning approaches for federated learning and let's say estimation-based full of the state of the system in a localized manner. So observers that are using deep learning to do so in a local manner, in a distributed manner. And of course, we are also aiming to use distributed ledger technologies for authorization and security aspects as well. Just in a nutshell, right?
Indeed. Thank you very much, Jakubos.
And if I may jump in, hi,
yes.
This is Vasilis from the University of Athens. We have a dedicated presentation for the key technologies that we will try to summarize. What are the key technologies that we will be used in the context of this project in order to reach the objective? So be patient, people. But thank you very much for your question.
But yeah, it's very nice that people are listening. Yeah, so that's wonderful.
All right.
Right, let's move on then. We're going to go into the technical approach now. And here I'm going to introduce again Vasilis. I won't say your surname because I'm going to get it wrong. Who will cover, no, he's not. I've gone too quick. I'm actually going to go back and actually say that we're going to have the computing swarms concept from Jacopo Castellini. And what is nice is in the chat, I'm seeing people who have related efforts. Please do punch this in because, this could be a follow-up webinar with many of you where we can exchange, obviously, best practices. This is what we want to gain out of doing these efforts. Jacopo, the floor is yours. Thank you.
Okay, thanks, Silvana, and hi, everyone. So let me share my screen. I guess you can see it now. Okay, so in this session, I'm going to tell you a bit about the computing swarms concept and swarm intelligence. So let's start with a definition. What is swarm intelligence? Swarm intelligence is the behavior of a set of decentralized and self-organized agents. Actually, this definition applies both to natural agents or artificial agents, which is our case. And usually, the behavior of such a set of self-organized agents leads to the emergence of an intelligent global behavior that is actually unknown to the individuals that are part of this swarm. So in the figure here, for example, we see an example that that actually comes from natural agents, ants specifically, but it has also been applied to AI. Ants, basically, when they go searching for food, they leave the nest and move randomly around in search for food. And they leave behind them a chemical trail called pheromone, which evaporates under the sun. When they eventually find the food, they got back at the nest, and another ants start leaving the nest in search for food. The ants leaving actually smell the pheromone, and the stronger the level of the pheromone that they find around, the shortest the path leading to food this is going to be. Eventually, what happens after many ants has been doing this path is that all of the ants are taking the shortest path because it's the one that is more impregnated with the pheromone, and they are capable of reaching the food source in the shortest amount of time without actually knowing what's going on. An ant doesn't really know that if they're leaving pheromone behind, this is going to lead them to the shortest path. So there is an emergent behavior coming from the behavior of the colony of which none of the ants is actually aware of. So this and many other approach in Nether has been an inspiration for artificial intelligence strategies to address complex problems, for example, optimization problems, in a scalable manner, where scalable means that we can gain benefit from having more resource, but also that each agent, each unit that we use for our computation doesn't need to be extremely powerful because it doesn't have to compute the entire solution on its own. Just to name a few, we got genetic or evolutionary algorithms, particle swarm optimization, ant colony, similar to what we just discussed, and many more. However, all of those that I've just been listing are non-learning strategies. That means that those algorithms are given with an instance of a problem and they compute a solution for that. But then as soon as we change this instance by even the slightly less bit, we need to recompute the solution from scratch again. And this is, of course, not what we want for our HYPER AI setting, because we are going to face a never-changing scenario, basically, where resources and tasks from user are gonna get in and get out of our environment constantly. So we need to get a solution that is capable of generalizing across different scenarios and also is flexible to such differences. So what we are thinking of doing is to use machine learning, because machine learning is capable of learning this kind of general solution. Specifically, among the many techniques of machine learning, we are thinking of resorting to multi-agent reinforcement learning, that is combining this idea of having decentralized local agents. So each one of them is just computing part of the solution, basically. And the process of reinforcement learning that is basically based on a trial and error mechanism where the learning is solely led by a set of rewards and penalties. So all of the agents are basically oblivious about the problem that they are trying to solve. And with this, we aim to have a set of agents that can operate in isolation, first of all. So each resource, each node in our cloud service can be used, but also that leads to the emergence of some intelligence behavior. So I want to give you a couple of details on multi-agent RL in a nutshell, basically. Each agent is given with just a partial observation of the entire state of the system. So we do not assume that each machine in our cluster or in our cloud service is capable of observing everything from everyone, because that would be a very restrictive assumption, actually. And they have a set of actions that they can decide to perform. When each agent has been choosing an action and they are performing that, the environment, in our case, the cloud continuum, responds by transitioning to a next state influenced by the action of the agents, actually, and providing some numerical signal called reward. What multi-agent RL is doing is using this reward by some statistical formula, actually, to learn what they have to do, and then they will process repeat in an iterative fashion. Our aim is to learn what we call an optimal behavior, that is the behavior for each agent that is capable of maximizing the sequence of the rewards that we obtain along a series of such iterations. Okay, let me draw some connection with our HYPER AI frameworks now. So this is a schematic explanation of how we think of using multi-agent RL within the HYPER AI framework, actually. So we have tasks that comes from the users. Those tasks are divided into containers or pod. Each one is requiring some level of resources, for example, memory or CPU or storage. And then we have a set of nodes. Each one, again, given with a set of resources that can be used or free, depending on what the nodes are running. We are maintaining a queue of available containers that the nodes can select to start executing. Let me connect it to the multi-agent RL, as I said. So each node here acts as an agent in the swarm sense, actually. So we are allowing for decentralized execution. Also, each of the agents is only capable of perceiving its own level of resources. So he's not asking the other nodes what is their situation. And this is good because the number of nodes is dynamic and can change. And of course, communicating with every node in a cluster or in a cloud service can be very expensive. And they know information about the containers that are available to be executed. Then their action corresponds to selecting an available container from the queue of containers that can be executed, or doing nothing if the resources are already taken and there's no room for any additional execution. And then the environment, that in the HYPER AI case is the cloud continuum, basically, updates its state based on what containers have been selected to be run on the nodes, any eventual new tasks that are coming from the users, and so on. Then as a reward, we can optimize for many measures, for example, the overall execution time, the average delay, or in principle, any combination of measure of cost or efficiency. So, okay, the application of AI and machine learning techniques to the task scheduling or resource allocation problem is not new. The point is that usually those works comes from academia, where they are usually simplified and done in simulation settings, which just trace away many of the difficulties that we actually have in the real world scenario. Conversely, we aim at integrating those technology into the Kubernetes framework, so a commercial orchestration product. And we have to deal with all of those difficulties that come from the ever-changing real-world scenario, other than those coming from machine learning itself, of course. But we hope that computing swarms are going to help us with this. As a remark, and as an additional motivation for the use of swarm intelligence techniques, I would like to cite a couple of success stories from those and multi-agent as well. So swarm intelligence has been used by the US military system for controlling unmanned vehicles in war scenarios. Or another more light-hearted example, actually, is that in the Lord of the Rings trilogy films, which is one of the best films ever, I have to say, a multi-agent technology called Massive has been used for rendering the battle scenes, for example, the Battle of the Helm Depth. Or more recently, AlphaStar from Google DeepMind has been that is using, amongst other technique, population based on multi-agent RL techniques, has managed to beat by 5-0 top professional players of StarCraft 2 under professional competing rule. This means that has been playing better than professional top players in an unrestricted game like a human would play. That's it for me. Thanks a lot for your attention.
Excellent, Jacopo. I didn't know that real world examples at the end. That's incredible. And great that we're seeing some movement in the chat. That is extremely good. I'm not sure if we have any questions for you at the moment. Hang on, bear with me a second. Just so you do know, we will be picking up with the chats and getting back to the members of the audience who are writing parts in here. Let's see if we could. I would maybe take a couple of questions at the end, Jacopo. Okay, so let's maybe move to our next speaker, just for time reasons. So we're still in our slot, so timing is good. Our next speaker is Vasilis Papataxiaris. I did do your surname this time, and you're going to touch upon, indeed, the key technologies and innovations that has also been cited for this type of input by one of our audience members. So that's great that we're on cue on this. Vasilis, I'll pass you the floor. Thank you.
Indeed, Silvana, thank you very much for the introduction. Let me share my screen.
So that's coming in now. Hang on a second. And you're on. Yes.
Okay, great. Great. Thank you very much. I'm Vasilis from the National and Kapodistrian University of Athens. I'm a researcher there, and I'm very happy, based on the statistics that Silvana kindly shared in the beginning of this presentation, I'm very happy as a researcher, because I saw that most half of the audience come from the research domain, from the research community. So we're sharing similar and common interests and concerns. So I will have the clumsy, but at the same time very joyful role to go into more technical details of the project architecture. I will try to go quickly through the different technologies, the key technologies that govern the operation of the system. HYPER AI is dealing with the so-called cloud computing, continuum, and we're dealing with multi-edge, multi-cloud infrastructures and different heterogeneous types of technologies. So we have a multi-layered architecture starting from the bottom with the different types of computational resources, and then building on top of that based on key different technologies. We try to abstract the management of those resources. We go up with the self-chop operations and then distributed self-protection. And finally, in the upper layer, we deal with a set of technologies that try to abstract and hide the complexity from the developers and provide a set of tools that will help them deploy their own applications to the system. So starting from the resources abstraction, this is one of the most important goals in this project. We will try to implement a set of functionalities for the whole life cycle management within the computing continuum. This includes the management of different types of resources, different types of computational network, and other types of resources, but also the self-advertising mechanisms in order to facilitate simpler and faster development and deployment of applications, of cloud edge applications. So this is one of the most important things. We also include self-advertising mechanisms. Every node should be able to say that I am here, I'm available to offer these capabilities, and collaborate with the system in order to take over to undertake the responsibility of executing different parts of the different types of applications. And how we achieve this? By using semantic models. We deliver a set of open models for the semantic description of the resources composing the different layers of the continuum. We try to abstract the representation, the semantic representation of the cores, of the CPU resources, memory resources, GPU availabilities, and different other types of information and parameters that are handled by the system. And we want to do this in an optimized way, based on, we don't replace things that are already there. We try to reuse things and take advantage of them that have been developed in the past. And this includes KRM, Kubernetes resource model, and the OASIS specification, the Tosca specification from OASIS. Moving to the cognitive cloud softwareized architecture, we build a set of connectors. Another very important aspect of this project, different types of connector for different types of hardware. So for instance, if we go with a typical Kubernetes infrastructure, then you have certain limitations like it's not a straightforward task to include different types of hardware like Android devices, etc. So we're trying to tackle also those problems and make our world a bit more open and inclusive, let's say, in terms of the supported hardware. Moving in more details regarding the swarms, even Jacopo told it in a very detailed way. We're dealing with autonomous self-managed computing nodes and swarms. So we have nodes that collaborate in order to achieve a common goal. And in order to achieve this goal, they need to collaborate, they need to exchange data, we need to exchange information in order to optimize their behavior in real time. Moving one step further, we deal with self-optimization and self-configuration. We try to distribute the operation of the system as much as possible. And at the same time, we take advantage of distributed AI mechanisms in order to deliver and reach reliable full state estimation across the computing hierarchy. So we use things like we support things like detection of abnormal continuum and system states based on information coming from different contexts. So we take into account contextual information in order to achieve situational awareness. Distributed and adaptive optimization. Here the ultimate goal is to deliver the intelligence components that will allow for the transformation of what we explained before, the abstract task descriptions that want to be executed over the cloud, over the computing continuum. So we want to transform the abstract descriptions into a concrete deployment of those descriptions over the HYPER AI continuum. So here we deal with different distributed agents in order to select the most suitable system configuration for the execution of those operations. We also have a dedicated layer for distributed self-protection. Here we build security, privacy, and trust mechanisms for both the data and the network in the context of a multi-edge, multi-cloud environment. So we're taking advantage of distributed ledger technologies in order to design and implement a decentralized data trust and data security framework. We also support encryption mechanisms for the data transmission and storage. And then we also have an AI-based distributed intrusion detection system for the cognitive cloud architecture in order to detect and prevent cyber attacks. Finally, we also have federated learning mechanisms that will ensure that sensitive information during the training of specific algorithms will not be disclosed. Finally, and this is one of the very important aspects of the platform, is that we try to hide complexity. We try to make things easier for our users. And by saying users, I don't mean only the users of the applications, but I also mean developers of the applications that will use the system in order to deploy their applications over the continuum. So we have an ID environment, a graphical user interface, in order to facilitate the deployment of those applications and hide the complexity of building those applications from scratch. This is just an example. I close this presentation with an example of all the different technologies that mentioned before. So here we have the HYPER AI user, which is the developer that has a containerized application in using different functions. And by taking advantage of the tools like HYPER AI ID environment, where we have the description of the applications and also the semantic description of the computational resources. We have the first deployment around the different layers of the computing continuum, cloud, edge, and the devices themselves. We monitor the execution of their operation, and when needed, we jump in and redistribute the different functions across the different nodes of the network. Thank you very much for your attention, and I will be happy to answer any questions.
Excellent, Vasilis. That was extremely interesting, and your compliments on your timing as well. But we have seen a flurry of comments here. I have a question. Well, it's not really a question, but I think it's related to the comments that I'm seeing coming in. I know Melanie's touched upon the part around maybe training, and I see Jacopo and Jacopo have replied. What's our take on the training part in here? We're obsessed now with finding new skills. It's difficult to retrain, the people who are used to working on efforts, but need obviously new skills to carry out activities on new innovations. How are we tackling this in HYPER AI? And a related question is, could we perhaps do something with the other cluster projects and we know some of them are on the call now, that can help maximize a sort of joint training, some of the examples you've just described, Vasilis. And this is open to anyone. In fact, if the other speakers would like to open their videos, you're very welcome to on this part. Please feel free to. Anyway, maybe Vasilis, you can answer this question first, maybe.
Yes. Correct. Thank you for the questions. This is a very important aspect, because at the end of the day, all of the projects that are working under this umbrella of the computing continuum, the ultimate goal of all the projects is to facilitate, to open the world and make all these different types of technologies accessible for the developers, for a wide range of developers coming from different domains. So in HYPER AI specifically, we consider two different types of users. One type of user is the user of the applications that will be deployed, but another very important part of the users are the developers that would like to deploy these applications. So not the final users of the applications, the far-end users, but the developers of the applications. And we want to make their lives easier, because currently there is no straightforward way to deploy a distributed application across the continuum. So we want to facilitate this process, and in the context of Hyper AI, we have an IDE, a dedicated graphical user interface that will try to hide the complexity, that will try to facilitate the different parts of this chain, of the development chain.
And I don't know, question maybe to the audience, and if you, I don't know if we can open mics or they can reply. Do you think this could be something that could be investigated with the other cluster projects that we could do in collaboration with them, those who do have the same challenges in their projects, without going too far off? It's probably an open question, really. I'm not sure whether we've got okay, Diego saying if you want to speak, you can just you can raise your hand. Anyone want to nip in on that? You can think about it then, and in the meantime,
Melanie wants to say something.
Melanie, excellent. Melanie, please, I think the floor, Diego will open the mic.
I hope it works.
It does. Hi, Melanie, how are you doing?
Hi, Melanie.
Okay, so thank you for yeah, everything is fine. So I'm very happy listening to these talks and seeing also this kind of project Hyper AI having very interesting approaches to tackle this problem. So I'm also working in a Mythos project. And we're considering the Azure Fog Cloud environment as a 360-degree architecture where I have now, of course, as you've seen already in the chat, the responsibility on swarms and defining agents and how they can interact. So I just wanted to reply to Jacobo's message and also a second one from Jacobos. So thanks a lot for replying also to my thoughts. So I think it's very interesting, and maybe this is something where we can really investigate for future to see what is really possible. Because in terms of the swarms, so the experience that we made also in other problems. So we already tried to use swarming rules in industry, in production plants. So having an optimization from the bottom up. So not a centralized computation, but really from the bottom up. And for us, it's always interesting because really generating local rules with neural networks, having like we just have in the chat, having this kind of continuous learning approach, things like that. This is quite hard because you need a lot of resources. You need additional things to do. And so therefore, we are also now at the moment searching and thinking about where we could find a good place for AI. So in terms of whatever kind of machine learning, we always already made our first experiments also with large language models. And we tried now to find a good position where could these kind of models assist the edge resource allocation. And I would be very happy to maybe share some thoughts after this webinar. And yeah, maybe we find here, this was your question, Silvana, a point to collaborate in future and to simply share experience and share your knowledge.
Indeed. And that's the greatest impact when we get with these webinars. If then something's created as a follow-up from this, then that's perfect. So that's thank you so much. I'm sensitive to time, so I'm going to move on unless anyone has anything they immediately want to say. If not, I would pass to our final speaker, Manos Bampis. If you can put your video on so we can see you. Hi, Manos.
Hello.
And you're going to give us a brief project roadmap overview, aren't you? So the floor is yours, and thank you. We can see your slides.
Okay. Hello, everyone. My name is Manos Bampis, and I will present you the Hyper AI roadmap and milestones. Hyper AI is scheduled to run 36 months, starting from April 2024 to the end of March 2027. Here we can see Hyper AI project timeline regarding work packages, tasks, and deliverables. So Hyper AI is organized to 10 work packages. Work package 1 and 2 focus on management and coordination of the project. Work package 3 establishes the conceptual framework, while work package 4 and 5 focus on research and development of the technologies for our swarm and optimization framework. Work package 6 focus on security and UX modules. Work package 7 and 8 focus on integration of the project and validation in our use case scenarios. Last but not least, work package 9 and 10 ensure dissemination, exploitation, and standardization for a sustainable future of the project. To better explain how we have divided our workflow, we will now have a brief explanation of each work package. You can see the leader and the duration of each work package in the left. So, work package 1, project management phase 1, focuses on the administrative and technical management of HYPER AI during its first 18 months. It ensures collaboration, managing the consortium participants, and work package leaders. Its tasks, among others, are defining the coordination approach, creating the data management plan, defining the risk management strategy, monitoring progress, and preparing all the essential documentation. Work package 2 takes from where work package 1 left and runs until the end of the project. Work package 3, state requirements definition, focuses on defining the user requirements and system characteristics to specify the HYPER AI architecture, as well as the details for the use case and evaluation. Work package 4, key enabling technologies, at system and hardware level, aims to develop the fundamental technologies for implementing the FAAS architecture within the heterogeneous HYPER AI environment. Its key objectives include resource abstraction across the computer continuum, implementing self-advertising mechanisms for node registration, creating open connectors for transparent resource management, and designing semantic models to represent application requirements and computer resources. Now, work package 5, distributed self-configuration, self-healing, and self-optimization framework, focuses on enabling smooth orchestration and efficient execution for hyper-distributed data processing applications, utilizing deep learning techniques, optimizing resource across the computer continuum, and enable self-configuration, healing, and optimization. While work package 6, distributed self-protection framework, focus on enhancing security and trust in the cognitive cloud continuum. This will be accomplished with the development of decentralized trust and security framework for transparent and secure data management and an owner-centric encryption mechanism for end-to-end data protection. Additionally, it designs a distributed intrusion detection system to prevent cyber attacks and addresses privacy and security challenges in federated learning, ensuring data protection without compromising model accuracy. Work package 7, prototyping vertical preparation and INDE, aims to develop an INDE for application deployment, integrating the platform's tools and pipelines. It is also in charge for preparing the HYPER AI prototype and adapting the project for the project verticals. Work package 8, application verticals and evaluation, focus on validating and showcasing HYPER AI. It defines environments and actors for comparable results, conditionates demonstrations to highlight HYPER AI's benefits, and validates its open reference architecture and cross-layer interoperability support across different domains. Additionally, Work Package 8 evaluates HYPER AI's innovative features across a wide range of applications in various industries and assess its impact, usefulness, and acceptability based on application findings. Last, Work Packages 9 and 10, dissemination, communication, and exploitation phase 1 and 2, work on showcasing HYPER AIs through branding, social media, and website, and ensure visibility across the globe. They also are working on showcasing the impact and results of the project through technical and business venues, demo stands, workshops, and webinars as the one right now. During the HYPER AI timeline, we aim to achieve the following goals. The project handbook and multi-aspect management framework should be defined due to month 6. The requirement and architecture will be finalized due to month 12. The release of the resource abstraction, interconnection, and semantic and application modeling should be done until month 18. Oh, sorry. Okay. The distributed self-configuration, healing optimization, and protection frameworks, along with the UX framework, should be released due to month 30. The prototype of Hyper AI platform will be ready for pilot due to month 30. I don't know why my slides go so fast. So, okay, I'm not really sure what happened here. The prototype of Hyper AI platform will be ready for pilot due to month 33. Availability of final applications, vertical demonstrations, and evaluation report is due to month 36. Our website went live at month 6. The initial plans for dissemination, exploitation, standardization, and open source ecosystem creation, it was established in month 9 of the project, and they will finalize at the month 36. And finally, the final project management will be completed due to month 36. Thank you for your time.
Thank you, Manos. So we did get then an overview of everything that's been done. We have come up to the hour. I'm not sure if we have any further questions on Hyper AI specifically to this presentation, Manos, but I think what's been good is that we've had some exchanges, and we definitely do follow up with the participants who are in the audience now. I'd like to thank also those of you who have put in a Q&A. I did know that there was one before. We will, as we said, there is the recording and the slides will be available, but I think we will be going one step further and making sure that the next iteration of the webinar, or if it's a training component, then we'll obviously make sure that those of you who are in this call now, we come back to you and we try and make sure that we do a cooperation effort rather than just Hyper AI. So this has served its purpose very well. So with that, I'd like to thank and give a round of applause to all of our speakers. Thank you so much for attending, and we'll be in touch. These will be up on the slides will be up. We wish you a very good lunch. Happy holidays. It might be too early to say that, but we'll tell that to you already. Thank you once again. Take care, all of you. Have a wonderful day.
Thank you, Silvana. Thank you all.
Thank you all.
Everybody.
Thanks,
Thank
Silvana.
you.
Thanks, everyone.
Thank you. Bye-bye. Bye.
Thank you to Diego and Veronica also for your support. Thank you.